this exciting episode we will be exploring a small set of the CICS functions in Z Abend Investigator. CICS information is usually viewed by performing an interactive reanalysis of a fault entry. We can use the iline command with a fault entry to begin our analysis. The report overview gives a summary of the abend. This includes the location within the program where the abend occurred and a list of the information that was collected for the abend. The synopsis includes a succinct explanation of the cause of the abend. In this example, there was an explicit call to exec CICS abend. Selecting the line number hotspot allows the compiler listing for the program to be displayed, giving additional context around the point of failure. Returning to the synopsis, we can also select data fields to view the storage associated with each. For pointer type data fields, the contents of memory is shown in hex dumped form. Moving to the event summary section, we can find out more about the call or link structure of the program prior to the abend. By default, the event summary displays all system and user application calls prior to the abend. We can choose to display only user programs by selecting the Application Only option, after which only the user code events are displayed, allowing for a higher level understanding of the application structure, without being overwhelmed by system implementation details. More details can be viewed by selecting each of the event number hotspots. Each event displays the load module and/or program which was active at that point in the call stack. We can get detailed load module information by selecting a load module hotspot. This will invoke either Z Data Tools or File Manager Load Module Analyzer. Significant insight can be gained in the Load Module Analyzer, such as the versions of each CICS within the load module or program object. When source code information is not available, the machine instructions surrounding the active instruction can be used to understand the program actions prior to the active location. ZAI can display source code information for programs if the compiler listings or debug information are available. In this instance, the abend source line is displayed as well as the type of source code information used. In this case, Enterprise CICS debug information was used. The abending CICS event can include the last value of the user exec interface block. From this we can see exactly the time the abending transaction started and the last CICS command in the program, in this case an explicit abend. The hotspot associated storage areas can be selected to see the formatted storage of the current program. We can see additional useful storage, including values of variables that were used prior to the abend. For example, we can see the name of the TSQ used by the program prior to abend. All other storage for the program is shown in hex dumped format. Moving on to CICS-specific information, we can find out much more about the state of the CICS region at the time of the abend. The CICS release is displayed and can be a helpful reminder to apply maintenance. The application ID and CICS transaction ID can be used to quickly identify the specific region and transaction which contained the abending program. Each of the CICS control blocks can also be viewed from at the abend time. Formatted system and user exec interface blocks are displayed and a large number of other significant CICS control blocks to assist in abend investigation. We can find out more about the storage used by the abending transaction by viewing the transaction storage summary. It is possible to view either the storage for just the current task or all active tasks at the time of abend. This can be done by selecting the All hotspot. The transaction ID and task number are displayed next to the other transactions storage. Total storage used for both user and CICS keys are displayed and an overall usage summary. When detected, storage overlays are also indicated next to any of the displayed storage areas. We can also view, in detail, all the current transaction storage by selecting the CICS transaction storage display. For terminal-based CICS applications, the last 3270 screen prior to application failure can be viewed with the last CICS 3270 screen buffer option. The last screen, if available, can be viewed normally or in hex, something very useful when invalid data may have been specified as an input on a panel, for example. For applications which perform many exec CICS calls, the summarized CICS trace can be used to see which calls were made and the status of each call. If the abend in a trace is displayed, the CICS calls prior to the event can be analyzed to understand the program flow prior. For power users, the CICS trace formatting option allows user-defined formatting of the CICS trace. A subset of the trace can be selected by specifying task or transaction IDs of interest. The other formatting options are explained in detail on the Help panel. Once a trace has been formatted, 3 formats can be selected using hotspots, the default, abbreviated, short or full. The CICS link command can be used to view a graphical representation of the user modules within the transaction. Detailed information can be viewed via the module hotspots, including the elapsed execution time within the module. The CICS Recovery Manager display can be used to view the unit of work ID, file control information and auxiliary temporary storage details. The CICS Levels, COM Areas, and Channels panel shows which channels or containers were utilized by the transaction. For each program in the transaction, it is possible to view the data in each of the respective containers. When XML data is present in CICS containers, it can be displayed in pretty printed format. When transaction monitoring is active, the CICS Transaction Monitoring Area Information Panel allows for investigation of the TMA control block. The information here can be utilized when no other transaction monitoring tools were active in the region at the time of the application abend. The TMA hotspot can be selected to format the entire TMA control block. For web apps, the origin IP address, which caused a transaction to be invoked, can be checked. The CICS Event Program Information display allows viewing entries from the processing program table related to the transaction abend. Selecting a PPTE hotspot allows further details to be viewed on each entry. For example, the date which the entry was defined and subsequently installed can be ascertained. For transactions that include asynchronous tasks, the Asynchronous Information Panel reports the parent-child relationships between each. A graphical map of the relationships between tasks can be displayed by selecting the task number. In this example, the parent task has 4 asynchronous child tasks. For applications with multiple levels of asynchronously called tasks, the relationships between each generation can be investigated by selecting the respective hotspots. The Abend Job Information display also includes additional details relevant to CICS applications. The datasets in the DFHRPL concatenation are displayed to assist in understanding why programs were loaded from the abending locations, such as when a module existing in multiple points in the concatenation either intentionally or by mistake. The execution environment also includes the ZOS version and CPU model. This can help understand certain abends, such as when programs use unsupported CPU instructions resulting in abends. The Language Environment Options section displays the CICS regions options, and any region-level defaults are indicated as such. Thanks for learning about some of the CICS Abend investigation tools in ZAI.